Our today's class starts with a question from a topic called linear inequalities, and I am going to write down the question, then we can start working it out. So this is the question. I'm told -5 minus 2x is less than -3. And the other part of what we have as our question is x over 5 plus 1 over 3 is less than or equal to 1. So I think I want just first to talk about these inequalities. And if you have ever had a chance of coming across these inequalities, you must have been told that this means less than. So if it faces this side, it can actually refer to a particular value being less than another value. I can say 2 is less than 3. And that makes sense to a mathematician. If I come up with such an inequality, this means greater than, and I would obviously say that 4 is greater than 1. That again makes sense. Someone else can come up with this inequality. This means not equal to. So this can actually have this example, so not equal to. I don't think 20, isn't it, is equal to 10. So I can just say 20 not equal to 10. Because 20 is greater than 10 and 10 is less than 20. So 20 not equal to 10. And you can also have this. You can also have this inequality. This means greater than or equal to. So I can come here and say x is either greater than or equal to 3. So that means any value that can get captured here in terms of the value of x can either be equal to 3 or greater than 3. So x can either be 3, so the 3 becomes equal to 3, or x can be 4, so 4 can be greater than 3. So any value of x can either be equal to 3 or greater than 3. So any value that you write down in terms of the value of x should be either 3 or greater than 3. That is the meaning of greater than or equal to. And the other one can be this. This means less than or equal to. A good example can be this. I can say 70 is less than or equal to x. So someone can rewrite and then say y is less than or equal to 40. So if I get to this, this means the value of x can either be 70 or the value of x can be more than 70. Because this means 70 is either less than x or 70 is equal to x. So the value of x can either be 70 or a value more than 70, because 70 itself is less than that x. If I come back to this one, this means y is less than 40 or equal to 40. So the values of y can either be 40 or less than 40. So I can either have 40 as the value of y, so being equal to 40, or I have the value of y as 39, because 39 is less than 40. So any value of y that can actually get captured to satisfy this inequality should be either 40 or less than 40. So less than or equal to. So I wanted you to actually get a picture of all this so that when you begin doing this question, you can be able to have a clear understanding of what you're supposed to do in terms of getting the answer. So you can just get back to the question, then you have to get the answer to the question. Now that you have an idea of all these inequalities in terms of what they stand for or what they mean in a language that anyone in mathematics can understand. So we will proceed to actually getting the answer to the question. So let's start with this first inequality. Now they're separate. It is easier for us to work them out. We shall just get this negative 5 onto this other side of the inequality sign. So we shall be left with the negative 2x on this side is less than, we have negative 3 on this other side of the inequality. Then negative 5 will actually end up becoming positive 5. So negative 2x is less than 2 because negative 3 plus 5 is just 2. We shall divide both sides by negative 2 for us to get the value of x. And this turns out to be x is greater than negative 1. There's something I want to tell you. In working out any equation or any equation that has to actually capture that aspect of inequalities, ensure that when you divide all through by a negative coefficient or value, you are supposed to ensure that the sign changes, the inequality changes in terms of where it faces. If it was less than, it ends up becoming greater than. Because if you divide a number by a negative value, it actually reduces the quantity or the amount of that value. So the value has to actually reduce. So that means if it was greater than, it becomes less than. Why? Just try to imagine if I had divided by a positive value. It would be x is greater than 1 because I'm dividing by a positive value. But now these are negative value. What happens? The value I'm going to get is going to be less. So x is now going to be greater than negative 1. So that is what I want you to actually get. Whenever a negative coefficient is divided all through in the equation you are solving, please change the direction of that inequality. Change the sign. Change the inequality. If it was less than, let it become greater than. Now, let's get to this. You've been given x over 5, then plus 1 over 3, which is less than or equal to 1. We shall first look for the LCM of 5 and 3. And of course, this is the same as over 1. So the LCM of 5, 3, and 1, that is just 15. So you'll just have this one getting multiplied by 15. We shall also multiply here by 15. And as well multiplied here by 15. So 5 into 15, that is 3. So 3 times x, that gives us 3x. Plus 3 into 15, that is 5. So it's 3x plus 5. Then it's less than or equal to 15. Because 15 times 1 over 1, that is just 15. So we shall take 15 onto this sign, and we shall have that 15 getting reduced by 5. So 3x is less than or equal to 15 less 5. So 3x is less than or equal to 10. We'll divide both sides by 3. We will not change the direction of the inequality because we are dividing by a coefficient which is positive. So that means our x is less than or equal to 3 and a third. Correct. 3 times 3, that is 9, plus 1, that is 10. So that is 10 over 3. So we want to combine this inequality. So the first inequality in terms of the answer is this, and this is the second. So the two solutions are combined. It's what we call a combined inequality, or a combined equation in terms of capturing all those inequalities. So we'll first come here and write x in the middle. We'll pick the first value, which is negative 1. Then pick the last answer, which is 3 and a third. Look at this. The first answer has x, the second answer has x. So what do? We put x in the middle. Then pick the first answer, negative 1, write it onto the left-hand side of your combined inequality. Pick the second answer, write it onto the right-hand side of that inequality in terms of that arrangement. Then you'll actually end up now coming here and saying, where is this sign facing? It is facing x. So please allow it to face x the way it is. It had faced x, so it must still face x. You get the point? You rearranged, so it must still face x. Where is this inequality facing? It is facing the number. So please keep it facing the number still. And that becomes a combined inequality. If someone talks about you writing down all the integral values that can satisfy this combined inequality, please just take note of the following. If you have this as your inequality, this or this, don't include the value. Don't include the solution. Okay. So if this is my value and I have these inequalities, please include the solution in your integral values. That is, include the solution in your integral values. So if the inequality that accompanies that solution is greater than or less than, please don't capture that answer or solution in your integral values. You're going to capture down. Then if it has less than or equal to or greater than or equal to, please include that solution in the integral values. You're going to write down in as far as your answer is going to be able to appear. Now we shall proceed from this end. Our inequality is less than. So you can't capture -1. So from -1, what do you go to? You go to 0, comma, then from 0, 1, from 1, 2, then 3, 3 and a third. It has this inequality. So please capture that one as well as your answer. So those are the integral values that you're supposed to write down as far as what can satisfy this combined inequality is concerned. So these are the values referred to as the integral values that can serve as our solutions in terms of satisfying this combined inequality in this question have been given by this examiner.